In this video, we're going to be talking about Ohm's law. Now, Ohm's law is one of the most important aspects you come across when dealing with current electricity. Of course, there are other laws. We have the Kirchhoff, we have the so many laws to talk about, okay? But then this is one of the basics, and then we're going to start with this, okay? Now, for Ohm's law, what does it say, and how does Ohm come about the law, okay, of which he named after himself, Ohm's law, okay? Now, first things first, in our previous video on current electricity, we dealt with something like this. We're having a conductor of which is contained sections, okay, with charges inside of it, okay? Now, we also talked about the current density. The current density is simply the ratio of the current to the area, okay? Current density is simply equal to current divided by area. That is what current density is. And then from our videos on static electricity, we talked about electric field intensity, which is equal to V over R. Our videos on static electricity also has a playlist, which is still in the on our playlist, okay, still on this channel. Now, what we notice is that as we apply an electromotive force on this cylindrical conductor, okay, as we apply an EMF along this conductor, what we notice is that this current density, it is then proportional to E. Okay, that means we'll say that J is proportional to E. Not just proportional, but rather directly proportional. We notice that what now? The current density is proportional to the what now? The electric field intensity, not EMF. So we notice that as we increase J, E tends to increase. As we increase E, J tends to what now? Increase as well, simultaneously. Now, since we say J is proportional to what now? E, what we notice is that the ratio of E, of J to E rather, becomes a constant, isn't it? So J over E is simply what now? A constant. And that constant is called what now? The conductivity. So we can now say that J is equal to conductivity times E. This conductivity is also going to play an important role in determining the conductance of a material, okay? So J is equal to what now? Conductivity, or the coefficient of conductivity times what now? The electric field intensity. We can choose to substitute for J and E into this equation. What then are we going to have? We're going to get I over A is equal to coefficient of conductivity times E becomes what now? V divided by R. Now, if we make V the subject, what then are we going to get? We're going to get V is equal to, now in this case, we might want to make use of L instead. So if I put L instead, because in this case, we are considering the whole length of the conductor, okay? So let's make use of L rather than R, okay? If it's in static electricity, we can make use of L or R, it doesn't really change anything, okay? So if I make V the subject, I'm going to get V equals I L over A times 1 over what now? Conductivity. So what you notice is that I separated 1 over conductivity from it. This is because this 1 over conductivity is still quite important, okay? And this 1 over conductivity is what we're going to represent as rho, okay? In this rho represents what now? Resistivity. So we're not having resistivity is 1 over conductivity. Now let's substitute. We're then going to get V is equal to IL times rho divided by what now? Area, okay? We're having IL times rho divided by what now? Area, another important formula. We're not yet done in deriving. L times rho divided by A is also an important what now? Value. So L times rho is also an important value which we are going to represent as R. Substituting in, we're going to get V is then going to equal I. Everything here will be represented as R. So we're going to have V equals IR, of which we will also have in mind that R is always L times rho divided by what now? A. Now these are two important formulas. From here we cannot derive or give a definition to Ohm's law. Now, after Ohm, the scientist named Ohm, did all his experiments and his proof, he arrived at V equals IR. So what he said was that this simply means that whenever we are applying a potential difference across a metallic conductor, what we notice is that the potential difference is directly proportional to the current, provided that what now? Temperature and other physical quantities are kept constant, of which the constant in this case becomes what now? Resistance. Okay, so as the current is moving through a resistor, okay, R, which is the resistance, is trying to what now? Pull the current or stop it from moving, okay, as V is being applied. Just the same way we have a resistance that is trying to oppose the motion of a body that is moving through space or vacuum, okay, that is also we're going to have. So for this case rather, we're going to have V is equal to what now? IR. So Ohm's law is simply saying that the potential difference between the ends of a metallic conductor is directly proportional to the current, provided that temperature and other physical quantities are being kept constant. Okay, so R is the resistance and it is measured in ohms. Now in our next video we're going to go in depth on resistance, resistivity, conductivity, as well as what we call conductors. Okay, all these are also some important aspects that we need to talk about on Ohm's law and current electricity in general. Okay, but for this video we're just going to talk about the Ohm's law, which we already proved that V is equal to what now? IR. Now how about when we plot the current against voltage for various materials, of which we know that it is not all materials that will obey this law, not all conductors in fact. That is why when I derived Ohm's law, or when I gave the definition rather, I said metallic conductor. Take note, I did not say a conductor, I said rather what now? Metallic conductors. Okay, now here are different graphs that we can use representing Ohm's law depending on what we are plotting. Okay, so generally we are plotting current against voltage. Okay, most people make the mistake of plotting voltage against current, although you probably get the same thing. Okay, it's a straight line graph. Okay, so I against what now? Voltage. Now for this, it means we are plotting the graph of Ohm's law of any metallic conductor. This is what we're going to get. Okay, now for this one, we're going to get a graph like this when we are plotting the current against the voltage for a neon gas. Okay, this is what we're going to get for a neon gas, and for this we're going to get a diode. Okay, why for this we're going to get a diode valve. Okay, so what we're having here for these three graphs, they are called what now? Non-ohmic conductors. That is, these three graphs, the neon, the diode, and the diode valve, they do not obey Ohm's law. Okay, that is why you are seeing it is not a straight line. But whenever you plot I against V and you get a straight line, it simply means what now? They obey what now? Ohm's law. So for here, we're having current against voltage. Okay, current against voltage, current against voltage, and as well as the current against the voltage. Okay, this is what we're going to have. So our plotting current against voltage is what we're going to get. Okay, so the reason I'm writing I against V in this diagram, because when you're not seeing V against I, you're having something different. Okay, for these three guys. Then for the one on top, I against V, V against I, you should get the same thing. It's a straight line graph. Okay, now there are certain materials that obey Ohm's law in general. Metals, all metals obey Ohm's law. So we have a copper, we have a platinum, we have silver. All these, they obey what now? Ohm's law. Okay, and then we also have electrolytes. Example, your CuSO4, that is a copper sulfate solution, also known as your vitriol. Okay, now it obeys Ohm's law as well. Okay, I think that should be one of a few electrolytes that obeys Ohm's law. Okay, so that is that for Ohm's law, and here are the graphs on the board. Okay, in our next video we'll be talking more about conductance, conductivity, resistance, resistivity, like I said before. Okay, and we'll get more insights on how resistance depends on these values. Okay, so if you did gain or learn something from the video, do it to leave a like. Okay, and put your comments if you have a question in the comments section. Don't forget to click on the notification bell, very, very important, so that when a new video is being uploaded, you'll be one of the first 2 persons that will get notified about it. Okay, and also don't forget to share the video with your friends, and then subscribe to the YouTube channel. See you in the next video. Bye.